The following is the video solution from JSDT Solutions. Question 3 says, in the diagram, P, Q, and R are vertices of triangle PQR. M is the midpoint of QR, and N, which is A and B, is a point on PM in the second quadrant. The equation of line QR is given by 2y minus 3x plus 9 is equal to 0. And we are also told that the angle of inclination of QR is theta. Okay, so the first question, 3.1, says, calculate the coordinates of M, the x-intercept of line PM. Okay, so it is the x-intercept. So at this point, we have the y value of that coordinate being equal to 0. So that's what we're going to do. Now, also just remember that they did tell us that this M was also the midpoint of QR. So we can just put that so that we know that as well. Okay, so let's go ahead and find M. We're going to take the equation 2y minus 3x plus 9 equals 0. And in place of y, we'll substitute 0. So this is 2 times 0 minus 3x plus 9 is equal to 0. So that just becomes 0. And this is negative 3x. But we can just leave it here and transpose the positive 9. So now we have negative 9. And if you divide both hand sides by negative 3, x is finally equal to positive 3. So the coordinates of M are 3 and 0. And that is our answer. Question 3.2 says, determine the equation of PM in the form of y equals mx plus c. So this line PM, given that we know that M is 3 and 0, we can find the equation of PM. So we would need the gradient first, and then we can substitute 1 point on that graph. So let's write down the coordinates of P and M, and then we're going to find the gradient. So here's the formula for gradient. Okay, and we're going to say y2 minus y1. You can take the second minus the first, or you can just say top minus bottom. So 12 minus 0, and then negative 9 minus 3. So 12 minus 0 is still 12. Negative 9 minus 3 is negative 12. So this, the gradient of PM, is equal to negative 1. And now that we have the gradient, we can find the equation. You can use y equals mx plus c, or you could use this equation. Y minus y1 is equal to the gradient, but we know that's negative 1, multiplied by x minus x1. And then in place of y1 and x1, we're going to substitute a point on PM. Right now, that point, we can go ahead and choose M since it's a simpler point to use. So that's x1 and that is y1. So saying y minus 0 equals negative 1 multiplied by x minus 3. And if we distribute, then y is finally equal to, because y minus 0 is y, and we distribute here, that is negative x and positive 3. So negative x plus 3 is the equation of line PM, and that is our answer. Question 3.3 says, calculate the size of theta. Okay, so theta is the angle of inclination of this line QR. So we have the equation of this line, and in order to find the angle of inclination, we use this formula, tan of your angle of inclination theta is equal to the gradient. So in this case, all we need to find is the gradient of this line. Okay, so since we have the equation, we can find it. So we'll take the equation of that line, and if we rewrite it in its standard form in the form of y equals mx plus c, then we'll be able to see the gradient. So the goal is to get y on its own. Okay, so let's leave 2y on the left is equal to, transpose the negative 3x to become positive, and transpose the positive 9, so it's negative 9. And then we can divide both hand sides of this equation by 2. Therefore, y is equal to 3 over 2x and then minus 9 over 2. So we can see the gradient is 3 over 2. Okay, so to find the angle of inclination, we say tan theta is equal to our gradient, which is 3 over 2. And so we need theta to leave. So we'll use the inverse of tan. So that looks like this, arc tan. and that will cancel that out. And we'll have to do that on both hand sides since this is an equation. So theta is equal to, and we can just say shift tan of 3 over 2. And that gives us, so we'll round off to 2 decimal places. So you see that 9 will round up to a 1 there. So it is 56.31 degrees. And that is our answer. Okay, moving on to the next question. Question 3.4 says, show that B equals 3 minus A if P, N, and M are collinear. Okay, so they're collinear, they lie on the same line. So let's look at P, M, and N, and let's see how B can be equal to 3 minus A. Okay, so this is P, M, and N. And we found the equation of this line already in question 3.2, right? We found that that is negative x plus 3. So we'll just keep that in mind. We know the equation of this line, y equals negative x plus 3. But what they're asking us to do is to show them that B, which is the y value of this point, is equal to 3 minus A. So in other words, they're just saying, find the y value of this point. And of course, it was 3 minus A, so it's in terms of A. So take this point as it is. If it is collinear, then it means that it lies on this same line. And the equation of this line is negative x plus 3. So substitute this point, the x and the y value, into this equation so that you can find the y value. And it will be in terms of A. Okay, so we're just going to take n, which is A and B, and substitute it into this equation. Okay, so this is our equation, and we're just substituting the point n, which is A and B. Okay, and so that is the y value is B is equal to, and we'll say negative, and the x value is A, so that's A plus 3. Okay, so as you can see, if you just put the 3 in front of the A, then B equals 3 minus A, because that A is negative. And there we go. Okay, so if it's collinear, it lies on the same line. And so that point lies on that line. So we can substitute it into that equation. Moving on to the next question. Question 3.5 says, hence determine the value of A and B if NQ is 5 square root 5 units. Okay, so this relates to the previous question. You see how they made us express B in terms of A. It was because of this. You would notice that if they give you a length of a line, right? If you knew the length of a line, but you didn't know 2 points on it, meaning you have 2 missing variables, it's not going to be enough to find that A and that B value. But if you express them in terms of the same variable, then you'd be able to find it because now your equation will only have 1 variable and you can solve for that. So that's the whole point here. So we're going to take NQ, which as we look at it here, NQ is this line, okay? This line over here. And you see it has N and Q. So they told us the length of the line. So we need the coordinates N and Q. But of course, we're going to express N in terms of A. So that's going to be A and then that 3 minus A. Okay, so let's take our points down. Okay, but B is now going to be expressed like this, 3 minus A, because we were able to express it in terms of A since we had the equation of a line which N lied on. Okay, so that's 3 minus A. And they gave us the length of NQ. So we're going to use the distance formula, the length formula. So NQ is equal to, or the distance of a line, we can just start there. And we put down the distance formula. And we're saying NQ is equal to the square root of, and that's going to be x2 minus x1. But let's try to keep the A's first. So we'll say top minus bottom. So that's A minus 9 all squared plus, and then that's 3 minus A minus 9 all squared. Okay, so this is what we have. And we know the length of NQ. So we're going to substitute in place of NQ. We'll say 5 square root 5 units. Okay, is equal to, let's just simplify this further. So we have the square root of A minus 9 all squared plus, and this is 3 minus 9, which is negative 6. So we have negative 6. So we just say negative A minus 6 all squared. Okay, so at this point, you see that the square root is in the way and it's stopping us from solving for the A that we're trying to solve for. So let's go ahead and square both hand sides of this equation. So when we square that, it breaks open that radical. So here, the 5, you see these two are just being multiplied. So the 5 gets squared, and that's 25, and it's still being multiplied by square root of 5, which gets squared and becomes a 5. So this is equal to, the radical breaks open here, and so what we can just do is distribute here. So a minus 9 all squared, you can square the first term, that gives us a squared, square the last term, that gives us positive 81. First times second term is negative 9a, but you're going to multiply with that by 2, so that is negative 18a. And then over here, square the first term, that gives us positive a squared, square the last term, that gives us positive 36, and then first times second term, that will give us positive 6a, and then times 2, and that gives us positive 12a. Okay, so still in terms of a, and we just need to solve for a. Let's put our like terms together. But first, 25 times 5, that's 125. So we have 125 over there. And then let's just put our like terms together. So that's a squared plus a squared, which is 2a squared. And then negative 18a plus 12. That's like saying 12 minus 18, which gives us negative 6. So negative 6a. And then the constant. So that's 81 plus 36, which 8 plus 3 is 11. So it's already 110, and then 7. So 117. Okay, so that is positive 117. And then we're going to transpose that 125. So we have 2a squared minus 6a. And what's 117 minus 125? That's negative 8. Okay, so notice how all of these terms have a common factor of 2. So we can just divide both hand sides of the equation by 2. So therefore, we have a squared, and then that is negative 3a minus 4 equals 0. And we can factorize now. So we know that a times a gives us a squared, and then we need factors of 4 that can give us a 3. So we can try 4 and 1, but you see that this is negative. So 1 needs to be negative, 1 needs to be positive, but you need to ensure that the middle stays negative 3. So give the negative to the bigger factor and give the positive there, because negative 4 plus 1 is negative 3. Okay, so that's minus 4, positive 1. And so a is either equal to positive 4 or a is equal to negative 1. Now, they told us something about a and the quadrant that it is in, or that point really. They said that this point is in the second quadrant, and we can see that. So do you see that this is going to be a negative x value, okay? It goes behind to the left of the 0. Okay, so I just made more space. So it means that, and I realized that I said x, this is a. Okay, so this means that a is negative 1. And if a is negative 1, this means that b, you can see that that y value is 3 minus a. So b would be equal to 3 minus negative 1, which is positive 4. So there we go. That is what a and b are going to be. A is negative 1 and b is positive 4. And that is our answer. Question 3.6 says, determine the equation of a circle having a center at O, the origin, and passing through point R. Okay, so this circle center is at O, this origin, and it passes through R. Okay, so something like that. We don't really need the diagram. But if this is the center and this is a point on the circumference, then all we need to find is R. We already know the center is 0 and 0. So R, how do we find R? Well, now looking at it like this, do you remember what they told us about this line QR? They said that M was the midpoint of this line. So we can find R using the fact that this is the midpoint. So using the midpoint formula, we are going to see these as our endpoints, Q and R, because those are our endpoints. We're trying to find the midpoints, but we already have it. So let's take Q and R, and that will be our X1 and our X2, because this doesn't have any points. You'll call it X and Y. So that's your X2, and then that's your Y1 and Y2. In any order, really, it's fine. Okay, and then that's the actual midpoint. So let's just get our points down. Okay, so using the midpoint, it's X1 plus X2, and just put down our formula. Okay, and we're going to say the midpoint, to find the midpoint, we'll substitute these values. That is x plus 9, so I'll just go in this order, bottom and top. So x plus 9 over 2 and y plus 9 over 2. But the thing is, we already have the midpoint of this line, RQ, that we're finding. Okay, so that midpoint is 3 and 0. So this is the actual midpoint of RQ, and this is the calculation for the midpoint of RQ. So they're the same thing, they are equal. Okay, so since they're equal, we're going to equate their x values. So 3 equals x plus 9 over 2. Therefore, you can just cross multiply. So that's that invisible denominator of 1. X plus 9 is equal to 6. And then transpose the 9. So 6 minus 9 is negative 3. So we found the x value. And now here, we'll say the y value, which is 0, is equal to this y value, which is y plus 9 over 2. Again, we can cross multiply, or you can just see this as multiplying both hand sides by 2. And so we'll have the y plus 9 equals, and 2 times 0 is 0. So y is equal to negative 9. And there we go. That is the point R. Now that we have the point R, we can find the equation of this circle. So R is negative 3 and negative 9. So they told us that this circle has a center at the origin, okay? And it passes through R. So the equation of a circle is x minus a all squared plus y minus b all squared is equal to r squared. But in this case, the origin is the center. So since the origin is the center, you don't have to write it like this. We can simply just say, because the center is a and b, since it's just going to be 0 and 0, x minus 0 is x, y minus 0 is y. So this can just be written as x squared plus y squared equals r squared. So this equation is almost complete. All we need is that radius. Okay, you can choose to find r squared however you want, whether you want to use the distance formula from the center of the circle, the origin, to r, or you just want to substitute it here. It's easier to do it like this. So this is our x and that's our y value, and we'll substitute it into this equation. So negative 3 all squared plus negative 9 all squared is equal to r squared. So 3 squared is 9 plus negative 9 squared, or 9 squared, is 81. So you see that that gives us 90. So we can just say 90 equals r squared. So therefore, the equation of this circle is simply x squared plus y squared is equal to 90. And that is our answer. Question 3.7 says, the acute angle between lines QR and the line with the equation y equals mx plus 4 is 45 degrees. Determine the possible values of m. Okay, so the possible value or values of m. So the main goal is to find this gradient. And this gradient belongs to a line with this equation. And what we did with that gradient is, of course, we would find the angle of inclination. And with that angle of inclination, whatever the angle of inclination of that gradient gives us, we took that, and with the angle of inclination of QR, we subtracted them, and they give us 45 degrees. So I'm going to put down a diagram just so that we can think this through. Okay, so the main goal is, in order to find what they're asking us to do, they are specifically saying that the angle of inclination of QR, right? We take that angle, and now I can't just say we subtracted by this. We would have to consider two possibilities. So we take the angle of inclination of line QR, we take the angle of inclination of this line, which we're clearly going to have to call it something. Let's go ahead and just name that. I'll call it alpha. So the angle of inclination of line this, I'll call that alpha. Okay, of course, that is the angle of inclination that it creates with the x-axis. So what is going on is we're trying to find that gradient. And in order to find that gradient, we need this angle of inclination. So now the goal is to find the angle of inclination of this line. Okay, so to find that, they told us that they took the angle of inclination of QR and they subtracted it by the angle of inclination of this line. Now, I can't just say it's like this, because here's a visual on this. So look at what is going on. We have Now, I'm sure we could use this diagram, but I don't want to complicate things. So let's actually just look at it on a very small scale. So we're going to have the line QR, which we already know what it looks like. QR is this line over here. It's an increasing function. Okay, so we have QR and it has a y-intercept. Let's just remember, what was that y-intercept? We definitely have it because we found the equation of it at some point because we needed the gradient. Okay, so the y-intercept is -9/2. And let's just put that down over there. So if this is at -9/2, so this is line QR, then this line with the equation mx plus 4, here are the ways that it could look. It could be a situation where we're actually saying that the angle of inclination of QR minus alpha gives us 45 degrees. And so for you to have done that, then this line QR would have to be above the line with the angle of inclination alpha. So it will look something like, maybe like that. Okay. Now, the reason I'm considering this is because remember that these are not drawn to scale. So this thing that even looks like the x-axis, let's just say it's not the x-axis, because if I had to say it is the x-axis, then I'm already assuming that they intersect at the x-axis, and they never told us that. So I'll leave it as a dotted line. I'm not implying it's the x-axis. But the angle of inclination, when we find the angle of inclination of this line, QR, then we will take that entire angle and subtract it by the angle of inclination of this line. Okay, I might as well change that to red since that's what we're calling alpha. Okay, so this is the first situation we can consider. This angle minus alpha, like that. Okay, so that is that line y equals mx plus 4. Now, the second situation we can consider would look like this. Let me just move this over. Here is the second case scenario. So the second case could be that alpha, to find that 45 degrees, we actually said alpha minus the angle of inclination of QR. And then that gave us 45 degrees. Now, in this situation, because it gave you a positive number, this will imply that this line, right, that line is actually above this line QR. So it would look like this. We could still have QR the same way it is. Okay, and then this line y equals mx plus 4 would lie above it. Okay, now before drawing that line down, let's just also take note that this has a y-intercept of 4. Okay, and we know that this y-intercept is -9/2. So if the y-intercept was 4, it would still work out there, given that this is not necessarily the x-axis. We're not implying that they intersect at the x-axis. Okay, so in this situation, what that line would be, or what it could also be, is instead of a line that is increasing, it could be a line that is decreasing. So this one has an acute angle. This one could have an obtuse angle. So it could look like this instead. Okay, so these are two possibilities that we're going to have to take into account. So this could just look like that. And again, the diagram is not drawn to scale. So in this case, here the y-intercept would still be 4, and here the y-intercept would still be -9/2. So we have to consider the both cases. In this case, alpha could be acute, and in this case, alpha could be obtuse. Okay, so let's look at how we can get to this. Okay, so remember, we can have an angle minus alpha and then it gives us 45 degrees, but alpha is still acute as long as it is less than whatever that angle is. And that brings us to our next step. We need to find out exactly what this angle is, because the whole point is you're going to take this angle minus alpha and it gives you 45 degrees. Well, we have the value of this angle, so it means that we can find out what alpha is immediately. Okay, so let's try and find alpha by finding that angle. We already had it. They asked us to find the angle of inclination at some point, and that was 56.31 degrees. So let's use that angle. Okay, so the two cases of alpha, what alpha could be is, if this is 56, let's just do the calculation over here. So we're saying that 56.31 degrees minus alpha is equal to, and let's just find that acute first so we can find that reference and see whether it should be obtuse or acute. Okay, so this is equal to 45 degrees. This is what they told us, okay? The difference between their angles of inclination is 45 degrees. So with this, alpha would simply be just transpose alpha. So you'll be saying alpha equals 56.31 minus 45, okay? So let's find out what that is. Okay, so that would simply just be 11.31 degrees. Okay, so this is what alpha could be. But remember, we're considering two cases. Alpha could be acute or it could be obtuse. So if it was acute, it would be 11.31 degrees. If it was obtuse, it would be this acute plus 90 degrees because it needs to be obtuse, meaning it needs to reach the second quadrant. Okay, so from here, we would simply add 90 degrees. Okay, and so this could be alpha, or alpha could also be plus 90 degrees, which will be 101.31 degrees. Okay, so these are the two possibilities of alpha. Okay, alpha could have been acute as well. 101.31 degrees minus that 56.31 would give us that difference of 45 degrees. Now that we know what alpha could be, the two possibilities, we can actually find that gradient. That was the whole point. We need to determine the possible values of m. So we know the angle of inclination of that line. So we can use the formula to find this, which is that tan theta, or in this case alpha, is equal to our gradient. So we're simply just going to say we'll find the gradient by saying tan, and the first angle we'll try is 11.31 degrees. Or it could also be that the gradient is equal to tan of this angle, 101.31 degrees. And let's just find out what those gradients could be. So the first one was saying tan 11.31 degrees. And that gives us 0.2000. So this is 0.2, okay? And 0.2, that's really just 2 over 10, and that's 1 over 5. Okay, so you can just check 0.2 as the fraction is 1 over 5. So that's 1 over 5. That's the first gradient it could be. The second, we would just have to change that to 101. So tan 101.31 degrees. And that, therefore, tan equals negative 4.999. That is just going to round up to 5. So negative 5. And that is what the gradient could be. It could be 1 over 5 or negative 5. And that is our answer.